Thank you for joining Megger Asia webinar. I'm Grace from Megger Hong Kong. Today, our topic is identify weak spots and improve SAIDI or SAIFI in distribution networks with Megger Grid Analytics. It is a live webinar presented by Mr. Rohit, who is the Senior Application Specialist of Grid Performance Solutions for Megger Asia Pacific region. During the webinar, if you have any questions, please type in the question box, which you can see on the left of your screen. We answer the questions in the Q&A session. At the end of the webinar, please have a fill survey, which is on the right-hand side. We'll be sending the presentation materials to those completed the survey. Attendees will be able to download an attendance certificate after they have finished the webinar and completed the survey. And the recording of this webinar will be sent to you in 2 days' time by email. So without further delay, let's start now. Thank you for joining us today. Rohit, I'll pass the time to you now. Thank you.
Yeah, thank you, Grace, for the introduction. Hello, everyone. Very good afternoon, good morning. So welcome to today's webinar on identify weak spots and improve SAIDI and SAIFI in the distribution network with Megger Grid Analytics. So our today's agenda, we are going to discuss what are the common challenges faced by the distribution companies, what solution makers come with on the issues what distribution network have, the principle of operation, installation type and its protocol, benefits of MGA, and also I have added few snaps of the MetaView software, how the grid analytics helps you to make our grid more reliable, and of course QA session at the end. Also during the session, if you have any questions, any queries, you can just park your questions in the chat window. So when we talk about the challenges which has been faced by the distribution company, first thing is there are various faults happening in the overhead lines, right? If we just list down, or if we just count one by one, the list is quite big. That is face-to-face faults, face-to-ground faults, high impedance faults, broken conductors, bird hit, power down, voltage and current unbalance in each other phases. So there are various faults happening in the overhead network very frequently. And whenever we have such type of fault happening in the network, we have our dedicated patrolling team, or we can say field engineers, field technician team in the substation, just do the patrolling from the substation, from pole to pole, or where they got some information from some one of the customer who has called them that there is something uneven happen in this location. So technically, the average time for the patrolling team from the from substation and to locate and resolve the fault is 4 to 6 hours. Of course, it can be 1 hour, depend on the location of that fault, how near it is or how far it is. So the average or tentative is 4 to 6 hours is the average time of that particular team to locate and fix the fault. So whenever we have such type of event happening, of course, for that particular 4 to 6 hour, there is a chance, or there is the zone where the power is not supplied to that particular area. So of course, this directly affect to the SAIDI and SAIFI numbers in the distribution network. Now, what is SAIDI? SAIDI stands for System Average Interruption Duration Index. SAIFI stands for System Average Interruption Frequency Index. So what is the duration of that particular fault has been done and how frequently happening? So this data has been captured on daily basis and weekly and then monthly and then yearly. They just calculate what was the condition, what was the SAIDI and SAIFI numbers last year compared to this year. And we have always the regulatories who always monitors this data, and we make sure that the power is supplied to the end consumer 24/7, and they don't have such type of faults, or they didn't face any issues that power not has been supplied, right? So of course, when you have such type of 4 to 6 hour time to locate, for that time being, there is always a loss of revenue for that particular distribution company. So it can be thousands of dollars, thousands of hundreds of dollars, $100,000 of that losses for that particular distribution company, for the energy not has been supplied to that particular customer. And when you have such faults, various customers has been affected. If it is more industrial, IT parks, data centers, and more. Of course, when we talk about preventive maintenance, so preventive maintenance is a big challenge, because in transformers, in cables, in rotating machines, we do various tests, right, which help us to understand the what is the healthy condition of my asset. But normally in the overhead lines, if somebody asks our team that can you just go and do the check how whether you have any issues or not. So doing preventive maintenance and finding weak spots, or we can say weak conductors, is very very difficult, right? Because you cannot, nobody can judge by just by seeing, or just by from the patrolling, just seeing that conductor is healthy or not. So like broken conductors, such events cannot be detected early stage, even you do so any if you do very frequent patrolling or not. Also, whenever we have such type of events, the team in the substation, they just re-energize that particular event at the line again just after a few minutes. Or nowadays we also using reclosers. So reclosers has been set in a predefined time that if any fault happen, recloser will automatically charge that particular line after a few minutes for that 2 to 3 times. So re-energizing that faulted line again create the issue much bigger, rather than just fixing at very early stage. And condition like broken conductor or high impedance faults, that means broken conductor, that means the conductor has been broken and it is hanging, or it is just fallen on the ground. And we all know the protection system in the distribution network is not that good, and it can detect the broken conductor fault. And normally the conductor is broken, the energize is still energized, and there is a very very high chance of accident that any human or any wildlife or any animals can be come into that can come into contact with that high voltage conductor and create a very big accident, and there is always a loss of lives. Second, when you talk about in safety, the high impedance faults where your vegetation's touching your plant, branches are touching. So this all things again unable to detect at very very early stage, right? So in all those things, safety has been compromised. So most of the all the distribution network has been suffering all this type of problems, and this was always a huge challenge for the distribution companies how to solve it. So now Megger has taken up this challenge, and Megger has switched our existing grid to smart grid to know the status, what's happening in our grid, not only what type of fault happening, but also to how we can improve our grid. So the Megger Grid Analytics is not only detecting the fault, but it's also help you to step from the existing normal grid to a smart grid with MGA. So Megger Grid Analytics empowers the electric company with unique visibility on their grid using the MS5000 sensors. So these sensors are installed on the overhead lines of the network, and those sensors continuously monitors the data and send to the meteorology software, where you can have all the details of the grids. So what are the fault events, heat map, and more. So we are going to discuss more in detail in upcoming slides. So first thing that is always comes in your mind, what is the principle of operation? So each set consists of three sensors. So we can just UVW, RYB, line A, line B, or line C, whatever you can just say the name. So there are three sensors which constantly record voltage and current information, and if something abnormality occurs in that particular network, those sensors detect those and classify what type of fault and send these details to the MetroV software. Or if you have already there's a SCADA or any database management software, we can just link to that as well. So there are two slave, one master, right? And this data has been sent from the master sensor to you to the the control room wherever you have installed the MetroView and SCADA. So the communication are two types, either cellular or with uh, radio. So the MetroView server stores the information from the sensors and performs more additional analysis and displays the result in the database management software or SCADA. So when we talk about the installation type, there are various methods. So just like I mentioned that there are two slaves and one master. So SU are the slaves unit which sends the data to master, and MS Python GS, in this we have a SIM card. Of course it supports 2G, 3G, 4G networks, and this sends the data to the cellular base station, and from there it captures from the to MetroV software and the SCADA. On the left hand side you can see some images how the sensors has been you know installed. So of course, yes, those sensors can be installed in the live condition without taking any shutdown using the hot stick and all the necessary safety uh, where. So it is very simple. Just we have a small hook, so you just need to open clockwise and anti-clockwise to open and close the jaw of the sensor. So when you just place it, rotate it, and you can just install those sensors in live condition without taking any shutdown. Second option is the mesh radio. So mesh radio is used where you don't have any cellular network, right? Let's say uh, you're in one of the city, and in the city area and in that zone, in tier 1, tier 2, tier 3 zone, you have a very good cellular network. But when you go a bit far in a remote areas, it can be where you don't have such good network communication, something. So you can use mesh radio options. So of course we can use the hybrid one. That means let's say you have 100 kilometers of distance. So first 50 kilometers you have radio, but next 20 kilometers you don't have network. So in the 20 kilometer you can use radio options, and then again cellular. So it is again very simple. We have again the master one send the data to each other, and then we put one high gain antennas in that particular area. So each antenna has a range of 10 kilometers, and also we can increase the distance depending on the high frequency antennas. And this sent to the main, again the master one, and then the same thing you can see in the MetroView and the SCADA. So we all know nowadays uh, cyber security is always a big threat. So Megger has really taken care of those things. So MS5000 sensors from save to master, it is always protected with the EES 128 encryptions. And then from the master one to the to the utility, let's say when we are using a SIM card, so it is a private APN SIM card. So this is dedicatedly issued by that utility, by the utility to that particular sensor only. So nobody can have the access, or nobody can take the data. And with the using of a private VPN, it goes and install send this data to our database management software like SCADA and all, and also to MetroView software for for more grid analytics when the customer want. And the software is installed behind the firewall, so it is again is completely safe. So in parallel, those sensors data which has been coming, it directly communicates with the MetroView software for the sensor management and the green analytics. And also all these channels are TSL encrypted and protected by a private APN. When you talk about the radio connection, yes, it also have protected by AES 128 encryptions. So users has access to the MetroView by the web browser only in the internal network. So it's not that anybody can open that particular website of the MetroView or the database which has been installed in the computer and can view. So it is completely safe, completely secured from the sensor to the database management software. So when we talk about the customer layers of value using the MS5000 sensors, first thing, we immediately get the location of the faulty network segments. That means MS5000 sensors are capable to detect any types of fault happening in the overhead lines, like face-to-face fault, face-to-ground, high impedance, broken conductor, change in voltage and current, bird hit, everything. So once you know that uh, what type of fault happened, where it has happened, when you have various number of fault, so there is a very easily for the patrolling team to reach that particular location at very early at the initial when the fault happened. It always reduced the cost search. It also reduced the damage due to re-energizing of the faulted lines because sensors detect that it is a permanent fault and this is broken conductor or it is face to face. So there is no use of re-energizing the lines automatically. It also reduced the average outage duration. That means SAIDI. So when you know when your team can easily reach to the fault location at very early, let's say earlier it was 5 to 6 hours, which has been now reduced to 1 hour. There's always 5 times your SAIDI and SAIFI has been increased, and the analytics and predictive maintenance options in the MetroView software help you to identify the weak spots in the grid. Also, like broken conductor, recurring of any arc, high impedance faults, missing phase, harmonics, etc. Everything can be detected with the MS5000. So once you know whether you have weak spots in the grid, that means your team can do a very early stage maintenance. So it again help to reduce the SAIFI, reduce the maintenance cost, and the customer have more good grid visibility, like what is happening in the complete grid. Like there's overload, direction of the power flow, somebody's power theft is happening in any location, DER related information, reactive power, volt, VAR, all those things really help in terms of grid optimization. So next, what benefited to the customer is of course safety. So the safety is increased drastically. It reduced the fire and electrocution risk. That means if you have any branch and it is touching to your conductor, it really help you to understand where it's happening. So no more fire. Any broken conductors have any cable is hanging, it really detects those things. No more such fatal accidents which causes any human life or any wildlife, right? So these are the layers of the values: immediate location of the faulty network segment, analytics and predictive maintenance, grid visibility, and increased safety. So it's the same what we have discussed. So The first thing with the MS5000, which really help you to understand immediately location of the faulty networks. So of course we have very big networks where the fault happened. It directly help you to know where the fault happened in which particular zone, so your team can directly go and fix that particular fault as soon as possible. So it reduce the outages time, meet the regulators requirement, and reduce the losses to the customers, reduce the losses of revenue from energy not supplied. It reduced the cost of surge. It reduced the damage of grid infrastructure due to re-energizing the faulted lines during the complete surge operations. MS5000 sensors also help in the analytics and predictive, like we have discussed in previous slides. Identify weak spots in the grids, impulse, leakage, broken conductors, recurring arcs, and high impedance fault, missing phase, harmonics. Detect location of the transient faults, which is now very hard to locate without such sensors. It helps to reduce the number of interruptions. That means your SAIFI is improved, your maintenance cost is reduced. You have great grid visibility. You can have directly know where you have overloads, direction of power flow, power theft, reactive power, and all. And also safety is drastically increased, detecting such hazardous condition, like like I mentioned, a fire, broken conductor conditions, each and everything. So detecting faults that something cannot be detected, any presence protection such as high impedance faults like vegetation touching to the lines, broken conductors in your network. So this two issues is a very big headache for the distribution networks, and they're really struggling to find such solutions. But MS5000 sensors can detect the broken conductors and high impedance faults, which has been vegetation touching or something, a plant or in trees touching to your particular branch. Immediate detection of fault locations eliminates the trial and error and reduce the repeated faults. So it reduce the electrocution risk and reduce the fire risk. When you talk about the sensors, so this is my HV conductor and this is my sensors which has been installed. In the sensor we have high quality current transformer which has a very good accuracy with plus minus 0.5%, which is too good, and has the range with the same accuracy up to 600 amperes. Of course, if you have any high current fault passing from it, the sensor is capable to capture up to 20k ampere. It means 20,000 ampere current can be detected by the sensors for a few seconds. It has very precise synchronizing between sensors between different phases, like more than 30 microseconds typical. It has designed for the operation of 10 to 20 years in field. It is completely IP67, and the material which has been used in the sensors is not a plastic or not any fiber. It is completely aluminum. So the life what we are guaranteeing that 10 to 20 is it is really helpful for the customer. No maintenance is required once you go and plug the sensors on the overhead lines. You just need to forget it. You don't need to go there, check, change the battery, nothing. This, the MS5000 sensors comes with the inbuilt battery, and the capacity of the battery with the backup is 2 years, and it charges by self from the line, which we say power harvesting. And even there is no power on the line, the sensor still will be on with the battery backup of 2 years. And the battery are self-charging. You don't need to replace the batteries like other fault passage indicators or some similar types of uh, normal fault indicators what we have in the market. So when we say that the MS5000 sensors are capable to capture all type of fault, so of course we have done a third party performance test, and we have done this measurements in University of Stuttgart. It's a power network demonstration center. And in the testing summary, they have confirmed that the sensors successfully detected 100% of fault that were tested, including the fault's location with respect to the sensors, the classification of the faults, and the faulted phases. And the sensor successfully detected 100% of high impedance faults, including 10K ohm with a fault current of less than 40 milliamps. So even that so the third party test lab has also done such type of performance test in their laboratory, and also that of in the labs, and also created some manual faults on the site. So if you need it, I can share this touching summary in future, so you can just let me know in the chat box so I can share the complete test report as well. So now moving to the grid analytics software. So it is state of art software. That means we have a complete visibility of the grid. That means once we decide in which network we want to install, so we just create a complete single line diagram in the software. So this is my substation, and from the substation there are two lines are going out, and this is the single line diagram of that particular substation. And this point 1, point 2, point 3, these are the location where the sensors has been installed, right? And you can see the arrow showing the direction of the power, and these are the red, white, blue current in all the three phases. So if you just click on, you can get more details. So whenever you have such type of such networks where we install the sensors, so we are more interested in how we can improve the networks, right, using the grid analytics. So the software captures all those details, like like in the fault events with date and time, when the fault was happened, what time, in which phase, what type of fault. That means it was a C phase with respect to ground. That means it is a phase to ground fault. It was a permanent fault, and the current passed during that faulty condition was 3.4 ampere. Also, again with that, it also created a complete analytics of total faults happening in the network, including the transient events happening in the network, plus self-extinguishing faults, right? So out of all these faults, you can have an easy understanding of the network's behavior over a period of time. And it also create a complete heat map. That means in which zone you have more faults, so the team can have a dedicatedly focus in that particular zone first, rather than other zone. So you can see in this image, in the green lines are the safest, where they don't have any faults happening in the network. This zone is the zone where you have maximum faults happening, so it is has been converted to red. So the team need to do dedicatedly patrolling and need to do a search why that is such events has been happening. That means some vegetation touching, some external thing is happening. So customer can go and do such, conduct a preventive maintenance test. Yellow is more the transient, sorry, self-extinguishing. That means the fault happened and it automatically get restored. That means some tree branch touched and again it has gone back to its original positions. So you might have such type of self-extinguishing faults. When you talk about the detailed analysis, whenever you have fault, you can just click in that particular sensor. You can get complete waveform analysis. What was my voltage and current waveform of that particular phase during the faulty conditions? How many cycles has been taken by the circuit breaker to trip that particular fault? What was my zero sequence current? Now zero sequence is very very important in terms of detecting high impedance fault and broken conductor. You have a daily load trends of the voltage and current, so you have a customer have more better understanding in which zone there is more high demand and what time. So fault location, which I have discussed, it is one of the good part. It easily identify what type of fault happen, where it has happened, in which zone. So it classified, locates the zone of that particular fault. So it can be traced quite fast. So no more patrolling needed from substation from XYZ kilometers. The patrolling team can directly go to that particular faulty zone and they can directly fix that particular problem. Dashboards, like I have showed in the previous slides, with details of all the different faults happening in the network, heat maps, which zone is more affected in such type of fault happenings, which zone is more healthiest, which zone is converting or switching to that particular healthy to unhealthy zone in coming days. So customer can have a very good visibility on the grids right from sitting from their offices, and they can also use the same thing from their mobile as well. So when we talk about the weak spot analysis, so I just want to share this one of the very good chart. So you can see this is my location where the sensor has been installed, like point 0.2, point 0.1, point 0.6, point 0.3. And you can see these are the faults happen in that particular zone. So point 0.2 was only 3 fault, point 0.1 was 5, 21 fault, and 84. And this is with respect to the date and time. So it the sensors also captures the weather condition as well, right? Whether you have quite rain happening in the network, speed of wind, some any weather conditions. So it also captured this thing as well. So it really helped to understand what was my network behavior when there was change in the atmosphere in the wherever the location it is. So you can see this yellow one are the cell extinguishing, red one are the transient faults, and permanently red are the permanent faults. So you can see this point 0.6 is a very good example that how at very early stage the sensor had detected there was various transient faults happening in the network, and this network has later on switched to a permanent faults, right? So this weak spots has been detected at very early stage. So this such type of chart is prepared in this network where it just plot all these different types of fault happening in your network, and you can just fix those things at very early stage before this transient fault convert to a permanent faults. Also, we also install, we also put all the details of the sensors, like what is the GPS coordinates, the KMZ file of the networks. So whenever there is any fault happening, the customer can easily open the Google Maps and he has very better idea where to go rather than just doing patrolling. So those sensors are capable to send SMS as well. So if you have a dedicated app, the team on the field, so they get an SMS in their mobile that this is the location where the fault happened, this is the sensor name, and also email notification to the authorized name of the list whichever you have shared in the software. So you get email and as well as SMS notification whenever you have a fault happening in your network. So the team that directly can fix and they can directly use this Google Map with the coordinates where the sensor has been installed, and they kindly go to that particular locations. So this is what I would like to conclude myself for this presentation. So if you anybody have any questions, any queries, you can just please. So if anybody have any question queries, please park in the chat window, and we're really happy to discuss the question quiz sessions.
All right. Thank you, Rohit. Here comes to the Q&A session. If you have any questions, please type in the chat box. Rohit will answer your questions. And for
Yeah.
those of you who are leaving, please remember to fill in out the survey, which you can see on the right-hand side. We'll be sending the presentation materials to those committed the survey. And also, don't forget to download the attendance survey kit, which is at the bottom control panel. You will see an icon on the right-hand side. And again, the recording of this webinar will be available in 2 days' time by email. So we will now spend about 5 minutes to answer questions you may have. All right.
Yeah. So we have one questions from
We got the
Mr.
first question.
Yeah.
Rohit. Yeah.
Okay, I will just read out and I will just say. So Mr.
Yes.
Diptiman Yadavji. So you have which location are this system installed in Australia? So this sensors has been installed in Australia, sir, like in various, like Orion is there in New Zealand and also in Australia as well. So we can just share these details to you personally. So our team will connect with you soon and share these details where we have installed in this, where we have installed in Australia.
Yes. Thank you. And the next question we have is, can an MS5000 sensors detect high impedance fault?
Yes, of course. Like I have discussed in the presentation, what is high impedance faults? It means some vegetation touching to your overhead lines, some tree which permanent branch has been touched, and which create a high impedance faults. And with the current uh, protection system like relays, which is there in distribution networks, cannot detect such events like broken conductor as well. So yes, MS5000 sensors are capable, and we can just share also some test reports where our existing installed sensors have detected such faults. So you can just contact us personally and we can share those reports to you.
All right. And the next question is, can we get Google location of faults happened in mobile?
Yes, just like I told that we just put all the GPS coordinates of the sensors in the Google Maps plus with the GPS coordinates of the your KMZ line of the distribution networks. So whenever such fault happens, it's the same thing is pop up in the Google Maps. So you can just log in the MetroView software and go to the map section, and you can have complete GPS coordinates and where you need to go. So you get the exact location of the faults happen in your network. Yeah. Next question, please.
All right. And will it indicate temporary or transient fault?
Yeah, it's a good question. So when we say temporary or transient fault, that means the fault has been uh, came and again gone at very instantly. There was in that particular one phase where you have sudden rise of current and again it's got stabilized. So it's one good example of bird hit. When you have bird hit in the network, you might have a spike in one particular phase. Yes. So it detects such self-extinguishing faults, transient faults happening in your network, as well as permanent faults. And we all know that transient faults also create issues in household appliances and also in normal networks where you have such transient voltage and current comes and a damage to your existing all the equipment. So yes, it captures such type of events.
All right. And next one is, normally, what is the battery life?
So battery life is up to 2 years once it's fully charged. But like I mentioned, we are using power harvesting. That means the battery get charged automatically from the overhead lines power. So it is self-charging. So if even the sensors are removed, or let's say in that particular network there is no electricity passing on that particular grid, still the sensors has capable for capturing the data and sending to the MetroView software for next 2 years continuously.
All right. And the next one is, can we integrate that with our existing SCADA system?
Yeah, so when we talk about such database management software or SCADA system, of course, we can easily integrate with that. We have a dedicated tech team who supports in terms of integrations, or you can also do by your own IT team. But yes, the system which we have, MS5000, is capable for SCADA and database management software. Even we are using DNP3 protocol or IEC 104 protocol. So it supports all type of protocol in terms of connectivity.
Okay. And next question is, can we use the system as data logger of voltage, current, and power?
Yes, because like I have mentioned in slide as well, so the system is capable to record voltage, current, power, harmonics, each and everything happening in your network at every interval. So you have a data logger which has been generated in the system. So the planning, the distribution team also have a planning team which help them to understand the grid stability, what or also understand the grid network usages. So yes, the data logger is available in that particular sections.
All right. Thank you, Rohit. I guess we don't have any more questions for the moment. If you have any further questions, please send us email to megahongkong@megger.com. You can also visit our website, megger.com/webinars for future webinars. And just a reminder, 2 weeks from today, 29th of June, we're having another webinar from Rohit, which topic is partial discharge measurements in GIS. So if you're available, please go to our website, megger.com/webinars to sign up for the webinars. The time will be the same at 10 o'clock morning Hong Kong time. So another reminder, please complete the survey and download the certificate before you close the webinar window. And again, the recording of this webinar will be available in 2 days' time. So thank you again for attending. Thank you, Rohit, for a wonderful presentation. Thank you, our panelists, Michael and Bernardo. We hope to see you all again next Thursday. Thank you. Bye-bye.
Thank you, Grace, for
Thank you, everyone.
Thank you,
Thank you, Rohit and
Thanks,
Grace.
Grace.
Bye-bye.
Thanks, Meg. Bye-bye.
Thank you. Bye-bye.